Good afternoon, everybody. I think we'll go ahead and get started. So my name is Trenton Franz. I'm part of the executive board of the National Agricultural Producers Data Cooperative. Thank you for joining us. Just a reminder of what exactly that entity is the overall goal of the project is to develop a blueprint for a national data framework and cooperative where producers, universities, and not-for-profit entities can store and share data and develop powerful tools that enable producers to maximize their production and profitability. So always good to remind everyone exactly what we're up to here. We'll have some updates at the end, probably from Jennifer, and kind of exactly where we are in that process. So today we're fortunate to have Ben Craker joining us from the oops, I lost my ag co-op. Sorry, forgot to he'll tell us where he's from. Sorry, I wrote it down. My face on it. Sorry about that, Ben. So anyway, we're going to be talking about industry-defined standards solving digital interoperability. Sorry about that, Ben. So
No
I'll go ahead
problem.
and turn it over to you, and we'll get started.
Yeah, I wear a couple different hats, so it's easy to get confused at times. So today I'll be representing Ag Gateway, talking about industry-defined standards. I'm the portfolio manager there. It's kind of my day job, I guess to say. So the idea here is we'll kind of do a little bit of an overview on Ag Gateway, and then I'll run through just kind of a kind of high-level overview of a couple of the different projects we're working on. So a lot of different things that are probably of interest to the NAPDC audience. So this is just kind of the high-level start of it. So expect maybe some questions will come out of that. But for a little background, Ag Gateway, if you haven't heard of it, is a member-driven nonprofit organization that's really trying to help with the transition to digital agriculture, and that's driven by a mission to develop the resources, relationships, and things needed to, for digital connectivity and data sharing to really happen. And I mentioned it's member driven, so we've got teams that we kind of stand up that are really focused on data interoperability throughout the whole ag value chain. So that starts, all the way back in the supply chain. Some of it is more like how does invoicing and inventory and billing get managed from input manufacturers through the distribution channel to retailers. Then we get into how things happen within kind of field operations and going a little bit farther down the line into processors and that kind of thing. And really just trying to get the data exchange to move a lot easier, a lot more efficiently, a lot more accurately, so that people can, we always hear about the data-driven agriculture and everything today, just trying to make that happen easier, so everybody gets more improved operations, profitability, sustainability, all the goals that I think everybody's probably familiar with. So just kind of give a little context to that on who our members are. This is just kind of a smattering. There's about 200 different organizations that are members of Ag Gateway, and that ranges from the big seed and chemical input manufacturers, equipment manufacturers, retailers, software providers, other organizations, kind of across the whole gamut of the industry there. So we've got a lot of different people and perspectives represented. Again, like I said, all the way from inputs through to some consumer goods companies involved as well. So quite a bit of different pieces of the chain there. And we are a global organization, so the roots were in North America. It started mainly in North America, but have since branched out. Obviously, a lot of the companies that are members have operations not just in the US or Canada. So we have a board that's elected from members around the world. We've got a regional director here in North America, then a regional director based in the Netherlands, kind of covering Europe, another guy based out of Brazil covering Latin America. Then we've had interest in discussions within the Asia Pacific Australia region. We don't have an official director there, but do have some interest and have added discussions on possibly expanding there as well. So kind of working on growing to make sure we cover all the different parts of the world, because when you start working with digital operability, there's a little bit different flavors of it around the world, but a lot of the core stuff kind of applies globally. So in my role as the portfolio director, I kind of oversee all the different working groups that we have going. within the portfolio management center, we call it. So we've got kind of two different levels of groups there. We've got advisory groups, which are more strategic. They kind of say, oversee a particular area. So, for example, we've got one that looks at field boundaries. People not familiar with industry will think about field boundaries like, well, that's not that big of a deal. But when you dig into it, there's a lot of different aspects of a field boundary and trying to figure out all the different pieces that you need to really have an interoperable system there. We established that advisory group, so they kind of set the direction on, this is the thing we need to tackle first, and then this is another aspect we need to consider, and kind of try to lay out a little bit of a plan on what we're going to work on with relation to a given topic area. So we've got field boundaries, agri-semantics, and then data linking are the current three kind of advisory groups we have. So then they identify, in conjunction with a couple other different paths, we start up a working group then to work on a specific set of deliverables. So our goal is to really try to keep the scope of a working group pretty limited. We want to be able to have volunteers show up and produce the results in 3 to 6 months is really the goal. Because we found if we make it a multi-tier project that stretches on for forever, it's hard to keep people engaged. So if we can kind of keep that scope limited, you can bring in the experts that are relevant to that particular aspect you're trying to tackle. So field boundaries is a good example of that, where we had a first working group that was really kind of a lot of the business people to just define terms, get everybody to agree on what a field boundary is, and document some of the use cases. And that was really all we did within that working group. And now we've just started a new one that is looking at the GPS or GNSS accuracy of a boundary. So that's, kind of a different specific skill set where we've got a new group of people coming together to kind of solve that particular thing. And then the big thing that Ag Gateway provides with all these working groups and things is the antitrust and IP policy for commercial organizations, universities. Anybody can come together and sit around the table and agree, okay, this is a pre-competitive space. We all agree that this isn't, a place where there's going to be a bunch of IP that people are going to be worried about. This is going to be us agreeing on how to move the industry as a whole forward, because the way we're exchanging data between trading partners doesn't make sense to compete on that. We all can agree that everybody's life is better if we just make this data move a little bit more freely. So we've got a join form there where people can go in and sign up and say, as a company, we are affirmatively joining this working group, and we understand the IP policy, and we know that we've got the antitrust policy in place as well. So we're not going to discuss certain things that would be off limits from that perspective. So it really kind of provides that framework to do a lot of this work that would be difficult, because we get John Deere and CNH and AGCO and companies like that all sitting around the table. They want to make sure that everything is kosher when we go to develop some of this stuff. And then across the bottom of the slide, there's just kind of how we generally work through these projects. So like I said, with the field boundary one, we kind of start at that higher level, just documenting user stories, use cases, and that leads to what, we call data buckets, but basically what the different data elements are that are needed within the context of that particular use case. And then it says gap check there, and that's because we really try not to reinvent the wheel. If there is an existing standard out there that maybe people just aren't aware of, or it's just not being adopted, we try to go gap check something like that and say, hey, this exists. It might need a tweak here or there for use in agriculture, or for use within this segment of agriculture. Can everybody agree to just make a couple tweaks to that? We'll use that as the basis and go forward, instead of, we're all really smart, we're going to go develop a brand new thing from scratch. That's really what we try not to do. We work with a lot of other organizations, whether it be ISO or ASABE, AEF, a lot of different groups out there, trying to make sure that we coordinate with them and don't duplicate efforts in that way. If we do that search and we don't find anything, then we are able to stand up, a working group that'll develop a standard from scratch. But most of the time, we really like to try to find something that exists already, and then we publish from there. And there's a couple different levels of publishing. Some of it we do publish through other organizations. We've had different projects where it went out through ISO, or it went out through AEF as kind of a guideline on how to use their standard, or a tweak or addition to their standard, or some of it's members only stuff, or a lot of it's available to the general industry though. So this is just kind of a recent snapshot of all our different working groups that we've had out there. And then I try to put a little hexagon up there on where they roughly fit within the value chain. So like I said, on the left, it's a lot more um, what I call supply chain IT infrastructure on how input manufacturers monitoring inventory with a retailer and invoicing and all that kind of stuff. You get to the middle, it's a little bit more farm management and then the field operations. So that's where we have a lot of work on exchanging data, traditionally what people think of as precision ag data. Then we get to the right a little bit more. It's how the data goes to elevator processors, things like that. So won't go through that full list there, but just kind of wanted to give you a little bit of an overview on where things are. And like I said, we kind of are a little bit unique in that we spread that whole kind of value chain within the ag industry of where we're working to try to standardize some data and work on interoperability. So that kind of leads us into the first one. Probably one of the things we're better known for is managing the ADAPT open source toolkit. So there's an ASAB paper out there if you're interested to go read that. It's a couple years old now, but I think the core concepts are still the same. And this really grew out of the as equipment modernized and everything got a terminal in it, then everybody had their own proprietary format. So the software company over here on the left is left looking at, well, this guy's got format A, this guy's got format B, this one's got, format X. And as a software company, I need to learn how to interpret everybody's different file format. Even, I mentioned we work a lot with AEF and they have the ISO bus standard or the ISO XML for the data coming off of these. Software companies found that there are even variations in how some of the companies are implementing that ISO standard. So it might be ISO flavor A, ISO flavor B. So that's where the adapt work kind of came up. Was this is a headache for all these software companies to try to figure this part out. A lot of effort being duplicated for each format. That's where we came up with the adapt framework. Was basically a common model, and we said, all right, if you're going to have your own proprietary format of data coming off of your machine, you need to develop a plugin that says this is how my data maps into the adapt model. So that way the software companies integrate against adapt once, and then they license a plugin for whatever data type or data format they need to work with from the people that are responsible from that format. Because that way the assumption is if you're responsible for that format, you probably are the one that knows best how it would map into a common model. So it put a little bit of effort from the FMIS back on to the different equipment manufacturers. And we as a gateway kind of passed the hat and did a little bit of work. We actually created the ISO XML plugin. So that was available under the same open source license. And that could then be kind of the basis for anybody making their own proprietary plugin on this is how you develop a plugin. So got a lot of different plugins out there for, different John Deere versions. CNH has a plugin, Climate, Precision Planting, a lot of different plugins out there. Been pretty well adopted. And again, that really eliminated the effort and a lot of the guesswork that the software companies had to do to try to read some of these file formats. So like I said, it's been really successful. The NuGet packages out there have been downloaded over 400,000 times as of last week. So we got a lot of adoption there. And this is global. We get, like I said, A Gateway just kind of manages this. This is an open source project. So you can go to the ADAPT framework GitHub and anybody can download that and contribute it. We get people from Ukraine, Australia, Brazil, all over the place contributing pull requests and things to that. And it's actually pretty mature and we don't get too many more changes on it anymore because like I said, it's been out there for a few years now. But today, like I said, it's open source. It is .NET based, but that's probably one of the main pain points is that's kind of a platform or language specific. It's interoperability toolkit. It's complementary. I don't know how many people are familiar with AgIn, but that's another project that AEF is working on to help with cloud-to-cloud data exchange from the equipment manufacturer side. So we work well with that. We support ISO XML, always improving, but there are some shortcomings. So it's not a standard yet. Even though some people will refer to ADAPT as a standard, it's not really a standard. There's no transport in it, so it's just really the data translation. There's no permissioning or security in there. We're assuming everybody's handling that on their own. Same with API, and it doesn't compete with ISO XML. It kind of works with it. And like I said, not perfect, but we're always working to improve. So kind of where that leads us is kind of the timeline. 2014, I think, is when we started working on Adapt. It kind of came out of a project called Spade with an A gateway. And then I think the first NuGet packages were published in 2016, if I remember right, early in 2016. And then kind of that list of things that is not, we realized that we need to make some changes to Adapt. The biggest complaint, like I mentioned, was not everybody does stuff in .NET. So we started an effort on the Adapt standard last year to really abstract that data model out of the toolkit and then make that available as like a JSON schema or something where it's platform agnostic. So it didn't matter what language you were doing things in, you would be able to exchange data without having to be a .NET shop. And then kind of as that started, we identified a need that, okay, once we get this standard schema on how we're going to exchange this, we need to have some sort of way to serialize this data as part of a true standard on how to exchange things from system to system. So we started up a working group to focus on that, where that was really all they were doing was kind of reviewing some of the technical requirements and things on how are we actually going to structure a lot of that high density data that gets exchanged from these field operations. And then we're on schedule right now. We plan to release version 1 of the Adapt standard at our annual meeting in November. So that's coming up really quick. I don't know if I remember to put that slide in here or not, but if anybody's interested, you can come to Nashville and see us there. Hit me up afterwards if you're interested. But like I said, we're doing the Adapt standard development within the open source community. The serialization part we did as a working group just to make sure there was no IP issues with there on selecting different technologies and things like that. But that's going to be published out through that GitHub project. So I'll have some links here on the next slide where you can find everything. We've actually been collaborating with NIST and OAGI and another standards organization to use a tool called SCORE to model this whole thing. And that allows you to express the model as a open API specification, JSON, XML. You can do it as like a CSV, however you want to express that to make it a little bit easier to use for different systems, and it supports versioning and all some other stuff that's pretty handy. So that's kind of the nickel tour of Adapt. There's a lot more information out there. You can go to adaptframework.org. That's probably the easiest place to start. That's the kind of the Adapt homepage, gives a little bit more background. But that'll have links to all the different GitHub repos to get the NuGet packages, and then the Adapt standard. We're just kind of managing that as a GitHub issue board right now. And that team's actually getting to the point where in the next couple of weeks, we should be publishing some of the first artifacts and things that'll be posted in there as we've kind of been working through that. So maybe I'll pause there, see if there's any Adapt specific questions before I jump into the next topic. If not.
So Ben, I had a question, which was just, as I understand it, Adapt is something that a software provider would want to like provide to users, as opposed to users having to figure out like how to use Adapt, right? It's really something that is a responsibility, would be a responsibility of the software provider. Is that correct?
Yeah, the easiest way to think about it, like if you've ever used like a FMIS tool where you have to go and import a DIR file or whatever, that all stays the same. It's just what's happening in the back end for that software tool is they're leveraging Adapt within their program to know how to read a John Deere file or a case file or a whoever. It's really a behind the scenes developer thing. It's not something the normal farmer would go out and use. It's something that gets integrated into somebody else's software tool. And like the stuff we're doing with the Adapt standard, that's really, I didn't get into kind of the changes we're making too much, but the original Adapt toolkit was really based around that idea of I have a task file, a USB stick, some sort of data card. The world has moved. We're all cloud to cloud now, so we got API connections, and that was one of the big things that we're doing with Adapt standard is when we abstracted that model out, we also want to be able to, well, I want to share just a chunk of this data. I don't want to have to send an entire task file from one cloud to another. So I want to send just the grower farm field tree to populate another system. So that's something that within the ADAPT standard, it'll really be more the APIs between clouds will get standardized on here's how we're going to exchange that data, having some rigid semantics around that, unit of measure, and some of that kind of stuff to make it a lot more consistent. So it doesn't matter whose cloud you go to connect to, it's the same way. But again, it's the, you know, equipment manufacturers of the world and the software companies of the world that are using ADAPT, not farmers or kind of end users.
Okay,
They benefit from it, but
sure.
it's one of those things that if everything works right, you don't know it's there.
You don't know it's there. Okay, right. Gotcha. Okay, thanks.
Yep. So next thing, next really exciting topic, lab test data. So we've got the MODIS standard, kind of starting with soil lab testing. So this is another area where there was, you know, a lot of data gets exchanged from system to system, not very consistently. The MODIS standard was out there in the industry as kind of a de facto standard, but it was really, you know, there's a handful of people from a couple of different companies that, man, this is a pain to exchange all this data. So they kind of sat down and put this together. It had a really strong controlled vocabulary of test methods. It also had an XML schema for exchanging that data, but there wasn't like an entity or an organization like who is MODIS or who do you talk to was a little bit vague. So that's something that, you know, as the importance of soil testing has kind of increased over the past few years, you know, people looking at some of the sustainability and soil health stuff gets to be a lot more important. You don't want to have errors in how you're exchanging that data. A lot of different formats makes for a lot of headaches. So again, trying to get everybody to move to one kind of consistent way of exchanging this data. We worked with the guys that kind of worked on starting this out. There's a good paper that they put together at an InfoAg conference, or I guess it was ICPA conference several years ago. We worked with them transferring all the IP and everything around the standard ag gateway. So we kind of took that over and everybody said, yeah, this is good. Could be better. So we started up a working group. We've been kind of working on going through all of that to kind of clean up the list of test methods. So that's really the heart of what MODIS is a clear list of methods that a lab uses to analyze a soil, plant tissue, water, manure, nematodes for different properties, and then report it back out. So in the context of a soil test, it gets to be really important to know what actual method was used to determine the amount of phosphorus in a soil. Because if you want to come back every couple, 3 years and check to see if you're impacting that, is it going up, is it going down? You have to make sure you use the same test method every time because different methods will yield different results. And if there's not clarity in what method was actually used, you don't really know if you're comparing apples to apples there. So that's where the MODIS controlled vocabulary was really good on identifying what test method was used. So we took that over, we made it open source. We've got a GitHub repo out there. Everything used to be in a Bitbucket repo. We've stopped updating that. And we plan to shut that down a little bit later this year. We're kind of giving everybody time to start looking at the new GitHub repo, just because that's where all the other gateway stuff was. So it's easier to manage it there. We're also in the process of updating to a JSON schema. All the cool kids do JSON now. Nobody likes XML anymore. So trying to clean that up and simplify it as part of that process. And we've actually got 2 different working groups going on this. So from that first list I showed with all the little hexagons, we've got the group in North America that was kind of leading the charge. And then we also have a team in Brazil where they have the same need to exchange data there. But they were really kind of gap checking the work of the other working group to make sure they're taking into account the test methods that are used in Brazil. They've obviously got more tropical soil types to have a little bit different methods. You know, some of the documentation on the process on who all needs what data throughout that sampling process to make sure we're capturing all that. So as we're developing the data models and schemas and things that we're taking that into consideration if there's any variances. We're also, we don't have an official working group, but we've got some people in Europe that are kind of tuned into this as well to try to align this with other efforts. So there's like a UNCFAC lore standard for exchanging lab test data that that was an XML one. Again, all the cool kids want JSON. So they're in the process of updating that. So we've been trying to get everybody on the same page here to hopefully have one kind of global standard for exchanging this lab test data. But then looking, you know, specifically at the soil test list, we've got about 820 different test methods in there right now. That's up from 600 that was in Modus 1. Some of that is just adding new stuff. So as you know, some of the soil health stuff has become more interesting, and they've developed some new methods for analyzing carbon content and things like that. We've added a bunch of new methods. Then we applied some, there's an ISO principle out there for observing and measuring. And we applied that ISO 19156 kind of abstract model to this to make sure we're documenting those methods clearly. Through that process, we figured out, you know, there's a couple methods in the list that, depending on how you looked at things on the way they're described, it could be two different methods. So we've kind of broken that out. So that's where there's the issue where there's some version 1 methods that might map to more than one version 2 method, just because we did provide a little bit more clarity, which meant you don't know which one it was for sure looking at a version 1 code. And then another big addition is we've added, you know, a citation. So where is this method actually documented? What regional manual? And that also gives us the ability, if there's a lab out there that has a proprietary method, this is supported. You can still document that was the method that was used without disclosing the, you know, the secret sauce and how you do it. But we can cite that it was, you know, this lab's particular method for doing that. So you can kind of see here where the extraction method really kind of broke out into 4 different columns. And that's where I said we got a lot more clarity within that list about that method. We've added a little bit more information on its status. So, you know, as we add, change, update, you know, find out, hey, there was an error in here, we can put some status codes on things. That's one big point that we are trying to call a little bit more as people start looking at these version 2 codes. We put deprecated on a lot of things just because in version 1, the method was maybe not real clearly defined. So we didn't know for sure what to put in. Like if nobody had a unit of measure, didn't have an extraction time, we had, you know, a lot of the guys that run the proficiency programs and know a lot of the stuff off the top of the head, but they looked at a couple and like, I don't know what this one was. So we marked it as deprecated, and hopefully if somebody's still using that one, the idea is they'll come back and say, hey, this is the info on what that method actually is. So we can fill in a little bit of that, more of that information, especially if we weren't able to dig up a citation for it. So like I said, we've been working through soils. So the plan is to have, hopefully we'll have version 1 of that new schema out at our annual meeting. Again, in November, we've got version 2 of the soil list out there, but we've been, in the last, I'd say, month, we've kind of made some more tweaks and changes, especially on the reporting units, getting it down to like 1 unit of measure per dimension, where before sometimes it was, you know, feet and inches and pounds, and other times it was kilograms. We've got everybody to agree that, you know, per method, we're going to have 1 reporting unit, and then whoever wants to do the conversion after that for what you want to display to your user, go right ahead. But we're going to try to really have a little bit more simplicity in the integration of this on the developer side, that these are the units of method that are measure that are going to be supported within it. So we'll have kind of a revision that'll probably come out at our November meeting as well. The other big change, I think, to Modus compared to what version 1 had was with Ag Gateway having it, we've now got a clearly documented process on how you go in and request a change. So if you want to add a new method, you find something wrong with an existing method, you can go out to modusstandard.org, and we've got these forms you can complete that are essentially drop-down lists for every column that I showed before on that table, to try to drive everyone to using the same controlled vocabulary for everything. So we're not, you know, having slightly different terms for the same thing. The idea is you go to that list, make sure your new method, the method you want to propose doesn't already exist. If you confirm that, then pick from known or existing terminology to add in that new method. And then we've got a process for reviewing that and kind of, you know, giving it the official seal of approval that everything's properly documented. You know, we're not going to say, yeah, that's a great method, or no, nobody wants to do that one. It's yes, everything's documented. We have the information in there. We can update the list and add that in there. It'll be in GitHub, so you can see the version changes and change log and all that kind of stuff to keep track of that a little bit more transparently. So kind of the snapshot on where we are. We've got, like I said, we got a version 2 list done. We're probably going to make a bit of a breaking change for that here in November, but the goal is to have that final or that big change done in conjunction with that schema. The assumption being anybody that's going to integrate this version 2 would do the schema and the version 2 code lists at the same time. Then from there, we've done a little bit of work on some of the other methods lists, but that'll be the next order of business. So we'll probably, start up a new working group to go through all the manure methods, and then a new one to go through all the botanical methods. It's not quite the same people always that are the lab test experts in soil that are the experts in the manure tests. So again, kind of once we get this one done, then we'll have a couple more working groups to kind of go through and add some of these other test methods in there. And again, like I said, it's all member driven, so it's really up to the members of Ag Gateway to say, we need a code list for whatever stuff we want to test, and we can add that in there with the overall framework of Modus. So you can go out to GitHub in the Ag Gateway repo there. We've got Modus started up, so you can find more information, or if you start at modusstandard.org, you can get the information there as well. So any Modus questions?
So I have a question,
yep.
which is, how does Modus, like, I'm trying to think of a context where Modus might work with Adapt, right? If you put your data in certain format, right? Or software providers providing Modus stuff, but it's not quite would you also have Adapt as well?
That's been talked about, and I don't know if we've thought through it all the way yet, on if we need to have like a Modus plugin for Adapt or something like that. We're trying to align, so like when I mentioned the change for the unit of measure stuff, I'm actually trying to get the codes that we use in Modus to be the same unit of measure codes that are in Adapt where it makes sense. But as far as Modus being in Adapt, we go back and forth on that, where there's kind of the knee-jerk reaction, well, everything should be in Adapt because that's the framework everybody uses. But then at some point, like, Adapt can't be all things to all people. So the soil, Adapt toolkit, the original one, was really focused on machines and the data coming off of them. With the Adapt standard, we've kind of abstracted that away a little bit. We've taken out a lot of the complexity on knowing, that I didn't get into the details, but as one of the big shifts was, no longer are we documenting this was the sensor and it was offset from the GPS receiver 16 feet back and 12 feet to the left, and it was delayed by 2 seconds from when the GPS receiver saw things. We're just saying, Mr. Equipment Manufacturer, you know all that stuff. Just tell us where it happened in the field. Give us a point, give us a polygon, and that's what we're going to exchange with it in the Adapt standard. So from that perspective, it might make a little bit more sense and be a little bit easier to include some of that Modus data on, okay, we took a core from here and here's all the attributes of it, and that can go through Adapt. I don't think that'll be in version 1 of the Adapt standard, but it seems like it might be a little bit cleaner fit than before, trying to have a soil sample in there when you need to have, a device model of how the equipment was configured was a little bit more of a, the end user of this data probably wants to know it, but I don't know if this is the pipe that they would connect to expect to find that. So we try to keep them aligned, but haven't kind of taken that step on officially integrating everything all together, but thinking about it, because we have the same discussion as we get into, we're looking at more stuff with like livestock. Adapt has historically been fields. Like, sure, you could call a pen a field and associate data with it, but I don't know if that's going to make sense or not. So some discussions to be had there yet.
Kristen had a question. Go ahead.
Thanks, Trenton. This is maybe a little bit too much in the how the sausage is made, but you touched on the review process for when somebody wants to suggest a change to the Modus standard, but I guess this could apply to Adapt toolkit also. What does that review process look like, and are those all Ag Gateway employees that are doing that, and is that that process, that methodology defined in like your bylaws or something? How is that?
So good question, actually, and it's a little different for Adapt than for Modus. So Adapt is open source, so there's just a couple actual volunteers that are also Ag Gateway members that are the chairs of the Adapt Technical Committee. And then it works like any other open source project. Somebody says, hey, this isn't right, I want to tweak it. They submit a pull request in GitHub. We have, I think it's every other week, or I can't remember if it's every other week or monthly, either way. The DAP technical team meets. That's a open source meeting. Anybody in the community can join that, and they review the pull request, and everybody says, yeah, that makes sense, or no, I need a little more time to look at this. But so the open source community is essentially reviewing that for technical accuracy, and it makes sense. Like I said, we don't want to include the code list for stuff that has nothing to do with agriculture in here, kind of thing. Within the context of Modus, that falls under that kind of agri-semantics group I mentioned before, where we have a little bit different process. It's kind of the same thing where we're actually working to formalize this a little bit more with an Ag Gateway, where we're establishing what's going to be like a standing committee to kind of look over all the semantic resources, all the code lists and things like that within Ag Gateway. And the expectation is, regardless of what list of things we're maintaining or controlled vocabulary we have, somebody would submit a request, and then there's some sort of triage that goes to I don't know, we're thinking on basing it a little bit like our social media is done, where there's, for 2 weeks, volunteer X is in charge of managing the Ag Gateway social media account. We're thinking the same thing here. For X amount of time, a volunteer of that agri-semantics committee is the triage person. So as a new request comes in, it's their job to look at it and say, yep, everything's documented, this all makes sense, I understand what they're asking for, we can move it along to the next step. Versus, oh, they didn't complete half the form, I don't know what they're talking about here, or this part's a little vague. Which is kind of what's laid out in this diagram here. It's probably too small to read, and then it goes to that committee, and then they review it. And again, like I mentioned, it's not to say whether this is a good method to include or not. Is it clearly documented? Does it kind of meet the requirements of what we need? And that is composed of Ag Gateway member volunteers. There's probably a staff member or two involved as well that actually make it happen in the background. But it's really that committee that's going to be overseeing any Ag Gateway managed semantic resources to make sure everything's approved. And that's where, if it's something really technical that you need to have a PhD in soil science to understand the test method, we'll know who to go ask a question to. We don't expect to have a standing committee for each semantic resource out there. It's more of a people that understand semantics and are passionate about that kind of thing to look at it and say, yep, that all makes sense. Or we need to go ask an expert if this is the way we want to do it. But if we can have enough guidelines, and that's something we've been going through with Modus, is providing enough clarity and definition on basically what each column of that table means, so that when people come to it, they say, okay, this is the information that they need to be able to fill this out and to do it consistently and to not use synonyms and kind of drive that kind of rigor. That's really what that committee is looking at, is did we check all those boxes? Then yep, we add it to the list and everybody's happy. So
yeah,
how it happens, I guess, is very similar, but the one's very open source. The other one, we've just got member volunteers that are kind of managing that kind of stuff.
Sure. All right. Thank you.
Yep. So the next one that I thought might be interesting that we're working on is PALE. So that's a clever name for an irrigation standard. That's actually, this is a one that's a good example of how we work with other organizations, where the team, it actually started out of a power company or cooperative in the Pacific Northwest that wanted to understand electrical usage by farmers when they're irrigating, because obviously that's a big draw on the grid. Kind of got this going, but then as they started looking into a standard for exchanging irrigation data, again, to try to make that more efficient, they couldn't find anything. We went and looked at like ISO 11783, the ISO XML that I talked about before. That's good for modeling equipment, but when you get to pivots and linears and drip irrigation systems, that gets really weird trying to shoehorn that into ISO XML. So they said, all right, there isn't really anything that exists. We're gonna kind of start from scratch, but learn from ISO XML or 11783 on this. And it broke down into 3 parts. Parts 1 and 3 actually got approved through ASABE and ANSI as US national standards. And then they went the next step and are actually working through ISO. So it's in a committee draft right now, 7673, all 3 parts. Part 2 is on observations and measurements. I'll kind of get into that a little bit here, but that's working through ISO to be an actual international standard here in the hopefully sometime mid next year, I think. Obviously, the driver behind this, water scarcity, a big issue for a lot of people. A lot of water goes into agriculture, so being able to manage that. This was Fresno State, I think, did this review of USDA, I think, Farm and Ranch survey on how much of the irrigation decisions are made using a scientific irrigation scheduling versus just kind of, we think we need to add this much, or the guy was out there and it looks dry, so he said, we'll put this much water on. So again, trying to get to more efficient use of water, doing it more data driven, that kind of thing. So you have all this stuff that goes into doing that. You have your on-farm weather stations, moisture probes, understanding your pumps, using imagery, and then, you know, sending that to some sort of advisor or an expert, and, you know, the risk management piece that goes into there. So you're going to have some decision support helping make that happen. And then that's going to come up with a couple outputs on whether you have just kind of a flat rate irrigation, or if you're able to do variable rate through your pivot kind of things. And then you're also going to have to, you know, in today's day and age, you got to have more reports on what you actually did, why you did it, trends and analysis. So really trying to standardize not only how you're going to control your irrigation hardware, but the data coming into that is also a bit of a hodgepodge of standards and proprietary things. So you got to get that all flowing to really be able to tackle this. You got to have kind of standardize the data coming into these decision support systems and tools and providers, and the data going out of it. So that's kind of what led to those three parts. So the first part of this standard is really just kind of the core concepts in terms and things like that. Part two is all the observations and measurements. So whether I'm pulling in data from the national forecast for a continent or country or whatever, or I'm pulling in data from an individual soil probe, you need to have some consistency, again, some semantics around that to be able to understand what's coming in. And then on the backside of that, you need the standard format on, you know, whether you're going to a pivot, a drip, linear, traveler, all these different kind of irrigation systems, how you're going to interact with those systems so they can control the irrigation going out to the field. So again, the goal is to promote the sustainability and better data management by providing that kind of industry-wide format to enable that data exchange for irrigation systems, both the data needed to inform the decision as well as the information coming out to actually make that irrigation system work. So again, just trying to improve that. So there's a format. It's really, you know, if you kind of compare it, it looks a lot like equipment did several years ago, where everybody had their own format. You know, depending on whose pivot you use, everybody's got their own format. They've all got cloud systems now. So trying to standardize that so all the different systems can work together a little bit easier is the goal here. And like I said, it's really kind of split into those two sides, where you got your observations and measurements, and then operations that go with that. So like I said, the slide kind of explains the same thing we had with equipment interoperability, you know, 10, 15 years ago, that has progressed. I don't say we've got it solved, but it's gotten better. Again, that's where irrigation's at, where, you know, if you got multiple brands of irrigation equipment, you've got, you know, it's worse in many senses when you got a bunch of different brands of soil sensors or weather stations and, you know, flow meters and all that kind of stuff that goes into it. To needed a little bit more work there. So that part of, like I said, the core concepts there is the documents or core documents. And one of the neat things is these are the same core documents that you would find in the ADAPT toolkit. So that's one deal that we did to kind of make sure everything stays aligned, where when we talk about this, these documents all exist, whether they're done separately or, you know, digitally, varies a lot by operation. So depending on your technical sophistication, this can all happen inside a farmer's head, or each one of these things can be a specific message sent from one system to another. So you've got your overall plan on what I'm going to grow where and when in a field. Recommendations are, you know, generally you talk to your trusted advisor on, you should use this hybrid at this rate. And then that will go to the actual work order. So these are the, you know, what you traditionally think of as a prescription on, I want to go apply X to the field at this rate in this location. And then the work record is, well, this is what actually happened because the guy showed up, he had the wrong seed in the truck, or this broke and they had to use this, or, you know, the no plant ever survives contact with reality kind of thing. So we need to document what actually happened. And then the observations and measurements inform all that on, whether it's, this is where some of the MODIS stuff fits in, or the soil probes, weather stations, that kind of stuff. And then you also have this reference data that kind of goes around everything on understanding, which the particular configuration of a machine on a farmer's field. So, you have the concept of the John Deere 8730 tractor, but I need to know the specifics about this one, what's the wheel spacing, hitch dimensions, and, all that kind of stuff that would be specific to that farmer's tractor. So that all rolls into here. So when you think about PALE Part 3, that covers I'm sending a work order, I have the recommendation, the plan, all that stuff through the work record coming back from the irrigation system is what's in Part 3. Part 2 is, again, based on that 19156 I mentioned earlier, is kind of this abstract framework for observations and measurements. We're really trying to position this as not only irrigation data, but this can be the framework for basically any sensor, any observation. So whether you're observing, I need to add more water to the field. If the crop scout's out there and says, I see these bugs in the field, that's really kind of the same process. So understanding how you document that observation to be able to make it machine actionable is going to be a big part of that Part 2, where the initial focus is on irrigation, but our idea is we can grow that a lot more to help kind of digitize and modernize other areas of agriculture on that. And then this kind of cooks a lot of, about 12 different slides on the technical side behind how that observations and measurements works down to basically a key value pair. So you can have, this is the value, and then this is the meaning behind that observation, what actually was encoded in there. So you can go look that up. We've been doing some work on some infrastructure to be able to do that. So it's a little bit more machine actionable to, very similar to what I went over with MODIS on, this is the property that was observed, this is the unit of measure, and whatever kind of metadata you might need around knowing what that value means when you transfer that from system to system. So the idea is similar to, I don't know how familiar everybody is with ISO 11783, but there's the DDIs, where you can go look up DDI 19 is, I don't, probably getting this wrong, I think it's harvest yield by mass per area. So that's clearly defined with units of measure. You know exactly what mass per unit area is. So having that kind of structure where you can go look up, okay, I've got, ISO 7673 Part 2 identifier for ground moisture at 2 inches of depth, something like that, to be able to really have that clarity when you get a value, what it means. Because so often in agriculture, you get that CSV file with no headers, and you're like, oh, it was 12. 12 what? We're trying to solve that problem with that observations and measurements framework. So any questions on that one? All right. Next one, field boundaries. Again, I thought that might be of interest to the group. Because if anybody's done anything with precision ag, the field boundary is kind of the heart of figuring out where stuff happened in the field, but it's also one of the biggest messes trying to exchange that from system to system. So we kind of started up, like I said, with that first working group, is really just trying to get to an unambiguous definition of what a field is that everybody could agree to. You would think it'd be that hard. My family makes fun of me all the time because I went to Des Moines for 2 days to argue about what a field was with people, and they thought that was a little bit foolish, that a field is a field. But out of that, I think we did get to a point where we had a pretty good definition of a field, and that kind of laid the groundwork. So now we can kind of start building on that. So as you exchange data from system to system, knowing what's coming, we put some categories around it. We documented a whole bunch of use cases that you need related to fields. And then we manage another tool called the agglossary.org. So we try to, it's kind of in the state of transition right now. We're kind of managing it through our Confluence system, but we're moving that over to a little bit more user-friendly system to manage all the definitions in there. But we're trying to provide the industry a place to go, especially a little bit more on the technical level to understand, when you see this term, what does it mean? So that's where we got the field and the field boundary definitions here that the group came up with, that we're working on adding into that system. We got a whole bunch of other terms that came up with that. A lot of that will show up in the adapt standard work that we're doing. So part of that, building that, obviously, as you're exchanging all that field data, you need to have a field boundary, grower farm field, all that stuff. In there, we're providing a lot of the definitions related to the field and field boundary came out of this working group to inform that adapt effort. We also kind of came up with a couple different categories, so it really helps you understand what that boundary was intended for. So, again, as someone receiving a boundary from one system to another, knowing a little bit about it, what it was intended for, what it can be used for, kind of thing is helpful. Because the conceptual boundary of what a farmer is thinking about in their head doesn't necessarily translate to what do I need to put into the sprayer to make sure I apply product in the right area. So did a lot of work with that. And then I mentioned that we just kicked off a new working group. We had a call to participation go out a week or two ago to kind of start that one up, really looking at the GNSS accuracy. So that kind of gets to the issue of, when you get a field boundary, is this a boundary that somebody had an iPad and drew it with their finger over some aerial imagery and you had no idea how accurate that is? Or is it something somebody had an RTK system and actually went out and drove that with a high accuracy GNSS receiver? And then we're even getting to I think we'll get into this on that working group, is understanding which RTK tower network they were using, because not all RTK systems are created equally. So as we're looking at more and more autonomous equipment coming into the industry, most every system I'm aware of on the market right now, or that you can kind of use, their first step is to go out and drive the boundary with their particular system, because they don't trust anybody else's boundary. And obviously the liability that comes along with operating an autonomous machine, that gets to be a lot of extra work to have to go drive your boundary every time you want to bring an autonomous machine in there. So what we're really trying to push here is, can we get enough information captured at the time that boundary is created, provide some guidelines for the GNSS receiver manufacturers and things to make sure we have that information. So when somebody receives that boundary, they can say, oh, some dude drew this on an iPad with his finger. We probably don't want to control our autonomous machine off of that. Or, okay, we knew they used this tower, this base station network. So if we can get on that same network, we'll be in a good shape. Otherwise, they used a base station that was surveyed in for 15 minutes versus I'm going to be using this base station that was actually surveyed in to be very accurate over, a 2-week process. That's why everything jumped a foot when I switched to this system. So understanding that kind of complexity. But then, I think we'll have a few other working groups that come out of this on, buffer zones are a big topic in Europe that keep coming up. So once we get that boundary kind of figured out, how do you understand what's happening maybe outside of the field, but in very near proximity? Are you next to a waterway? Is there, pollinators around, or that kind of stuff you need to worry about? How accurate did somebody actually drive it? Is there any way we can kind of measure some of that? Obviously, the field boundary and identifiers are a big topic. There's a couple different companies that have been starting up trying to help with that, especially as you look at people claiming carbon credits to make sure they're not double dipping, that they didn't use the same field in 3 different programs. Can we get to a common identifier? Some of that might lead to eventually getting to some sort of a field boundary format. I don't know how that'll work, but again, that's where that kind of advisory committee I mentioned before kind of looks at, these are all the different pieces we need to figure out related to a field boundary, and we can chunk them down into kind of one little project that we can knock out in kind of a reasonable time period. So that was field boundaries. Any questions there?
So I had a question, which was
Mhm.
that when a homeowner purchases a property, they usually have somebody come out beforehand and map out exactly, where the property boundaries are. So you kind of know what you're purchasing, because over time, fences move and things move.
Yep.
And right. So does something similar happen when, a farm changes hands and someone says, okay, I'm now selling my farm. I need to, does somebody come out and go, okay, you're going to sell it, so you need to map it in some way?
Yep. Yeah. So it's very similar when you sell land, that you figure out where the property lines are so that you make sure that, I haven't been farming the neighbor's 100 yards
accident.
for the last 200 years because we were all going off the fence post and somebody
Right.
moved that one night.
Right.
So that kind of goes into these categories here where, yeah, there is the kind of legal description that's used when you buy and sell land, which in the US that's not even consistent. Most people think of the PLSS, the townships and all that kind of stuff on the northwest quarter of the southeast half of the, section 32. Some parts of the US use that, other parts don't. There's meets and bounds and all sorts of weird stuff in the southeast. So there's a bunch of different ways you describe that.
Okay.
Most everybody's going to some sort of GPS, points and kind of thing like that to figure that out. But that kind of gets into what we call like the administrative boundary. Generally, that is a boundary that is defined by somebody else. You might be able to change it, but it's pretty hard. It's something you get from the government. You think of like reporting. I don't know. I can go back to my little picture here.
Okay.
So, this is kind of a good example. That orange block is 1 CLU. So that's how we would report this whole orange block to the government for everything. But this is a field, that's a field, this is all trees, this is a highway. So there's all this other stuff going on in there and how it actually gets managed at the farm level. And this is one example. I know people that have the other example where they've got one field that covers 2 or 3 different CLUs. So, that kind of gets into that. There's different boundaries at different levels. So what you need for an actual field operation in the sprayer is one thing, but you probably want to have that somehow linked to the description that's in the plat book on how you pay taxes and that kind of thing. So that's one of the kind of things we got into when you get in, as we were talking about this, is there's, a farmer might even subdivide that field differently on how they analyze it economically. They might farm it as one field, but the west side they own, the right side they rent.
Right.
So it's managed as one field by the sprayer, but economically it's 2 different things. So we tried to get into a little bit of that and provide, like I said, a little bit of context on how you link some of those different things on, this is the legal description. This is what's actually farmed. This is how the farmer thinks about it in their head. And this is how they subdivide it up economically. So there's all different boundaries. And that's where it kind of becomes important to know which one you have based on what you want to do to know if it's the right thing or not.
Okay. Thank you.
Yep. So the last one I was going to go through is data linking. And that's kind of broadly another, I mentioned that was one of our big advisory groups. And they, this is so broad that sustainability and traceability is a subset of everything they're thinking about on just how do you link all these different data sets. So they've got a couple of things that have been completed. So I think one of the best ways to kind of explain what they've been doing and how they think through things and what they've worked on is this in-field product ID is something that we kind of standardize or hope to get people to adopt and standardize on getting the right information into the planter. So, as planted data. The joke I think a lot of people probably heard, I've made it a lot of times, is the most commonly planted variety in the world is 1, because every farmer gets in their tractor, they hit 1 and they go plant. You have no idea what they actually planted. They have no idea what was in the sprayer tank at that. So what this group did was tried to link this is where Ag Gateway kind of fits in a unique role to take that supply chain side of things on. This is what was on the bill of lading or the invoice on what was actually delivered to the farmer. To have a unique identifier, the supply chain has that. They've got G10s and things like that on. This was the actual pallet of stuff that got delivered to the farm. And then the farmer takes that pallet of seed and puts it in the planter, and that's where the breakdown occurs. So the idea was if they could take that information and kind of the way we implemented this in the proof of concept was just put a QR code on the delivery document that the farmer could scan and use that to link data into their FMIS so that when they create their seeding map, that it pulls that identifier in with it. So we actually got to the point through this proof of concept where the list that showed up in the terminal was only the products, the seed, the 6 or 8 different varieties that farmer had actually purchased from their retailer. Because normally when you get into the tractor cab, it's one of 2 things. You have a blank and you have to type in everything. Generally, you're limited to like 24 characters and you got to get Roundup Ready to extend max +3 to fit into 24 characters and know what you're talking about. And oh, by the way, it had 3 seed treatments on it as well. The odds of that getting captured are slim and none. Or you've got this pick list of every known variety out there, which again gets to be a pain. The farmer wants to go plant because it's always going to rain, so trying to get them to do that data entry is a pain. But if we got it down to where just the stuff they purchased showed up in the terminal and we had the unique identifier along with it, so we actually could track, well, this seed had these 2 seed treatments, this seed actually had 3. When they got done, that identifier went along for the ride. So it wasn't overburdening the monitor and the machine trying to track that kind of data, because the tractor and the planter, they don't care what variety or what treatments were on there. They just want to know, is it corn and what rate? So we were able to make that kind of go round trip. So you can kind of see the flow of information here. So I think the blue lines were the data and yellow was actual physical things moving. But that allowed us to send that identifier, went along for the ride. So when we got done, we had an as planted map that the farmer had selected, whatever we named it intelligently. But that identifier linked all the way back to this delivery document. So we knew this was the seed, the actual variety, down to the lot and batch number, which is really interesting to a lot of the seed and chemical companies, because if there's something wrong with a batch and you got to do a recall, it's great if you can know exactly where that went and which farmer you got to talk to about what field, versus I delivered it to him and I have no idea where that stuff went. So having that level of traceability is really interesting. So we've really been trying to push adoption on that standard. But again, trying to show how we're linking that supply chain stuff through to the equipment operations and back to be able to trace everything through there. So obviously a lot of value there on not having to manually enter anything, only getting the stuff that you purchased to show up, and having actual traceability down to the lot and batch number. So a lot of benefits there. And this kind of introduces a couple of the key concepts this group works on that kind of are common throughout all the data linking stuff, where we have these, what's called the CTE, a critical tracking event, and a TRU is a traceable resource unit. So the tracking events are the transfers, transformations, identifications, different things that happen. And a TRU is the stuff that actually gets moved around and tracking that. So having those concepts work pretty good. So they've done a lot of work on seeding. They also did a simple, in quotes, harvest use case. So we did this with Jeremy Wilson, who's one of the on staff here, but he also farms. So they were trying to track where grain came from on his farm. So they had to have a connection with New Holland to figure out when the auger was on and off for the grain cart, because that's how you track the transfer events. They had to connect in a TopCon, because with Digistar, they had the weigh cells on that system. They had an ag leader yield monitor, so you needed that to understand that. Then you had to hook into AGCO to figure out when the combine auger was on and off for unloading events. And then one of our members has a little app to try to log all this stuff. So trying to figure out when you got close to a bin or a truck, or something that doesn't have much electronics on it, to know when it got transferred to what. So we call this the perfect storm. We got all these different clouds out there trying to connect all this data to figure out, everybody wants to know where the wheat came from in their bread, and like, that is really tough to figure out when you get to dealing with commodities. If you kind of ignore the whole commingling that you've just dumped, 3 counties worth of grain into one bin, we can kind of get back from there on, okay, we had a project where we now have a digital scale ticket, because all this was going off a paper scale ticket when it gets to the elevator. But to understand, we have a transfer event from the field to the combine, from the combine to a cart, from the cart to a truck, from a truck to maybe an on-farm storage, from on-farm storage back to another truck, back to a dump pit at the elevator, trying to track all those transfer events and be able to link them from system to system is what we've been working on here lately, is try to develop a standardized API for those key critical tracking events, as well as those traceable resource units, because that you can have multiple traceable resource units. One combine dump is a traceable resource unit. 4 of those go into a grain cart. The grain cart dumps those into 2 different trucks. So trying to track the different units of stuff and the events that go along with it gets to be pretty tricky. But if everybody wants to know the carbon footprint of anything, we got to figure some of this out to be able to make that data exchange work. So at the end, of that harvesting one, we got kind of the happy path was we have this highly digital scale ticket here. but we were able to link that ticket number back to where the combine was when it generated the yield data to go along with into that truck. So, that was kind of the ideal result, was you could take a scale ticket and say, this is where that came from in the field. Once it gets into the elevator and kind of gets commingled and everything, you lose a little bit, but we could at least do that piece of it. So yeah, like I said, the kind of the big main concepts they've been working there, and that wasn't something they invented. That it came out of some other papers. I think there was a university in Ontario or somewhere, Toronto maybe, that originally coined the traceable resource unit and critical tracking events. Then we've kind of built off of it. Some of our members have kind of written papers and other things out of it, but the easiest way I'd say to think about the traceable resource unit is the stuff, and the critical tracking events are the things that happen. So the transfer is an easy one that people think of, go from one container to another. You have transport, you can transform. So you're running the grain through a dryer. Now it's kind of a different thing when it comes out of the dryer because it's at a different moisture. It's maybe a different density, that it's been changed in some way. We had a good discussion with the guys at the Cotton Ink on this, where, a lot of the same concepts were applied to traceability there. So you think about cotton coming into the gin, you get that transform event where you have the lint coming out plus the seed. Again, a lot of different kind of things you want to track to be able to link all that traceability stuff back and forth. So got, like I said, some completed work there on that infield product ID, that shipped item instance I talked about with the seed use case. Data set metadata is another thing that they put together on trying to standardize some metadata for all, everybody's got their cloud system now, to standardize that. So when you go out and query these different cloud systems, it's a little bit more consistent on, can everybody have yield be the same thing, that we understand when I ask for yield, this is what we mean. Obviously agri-semantics, I didn't go into that, but that kind of underpins all this. That's another one of our big advisory groups where we're really trying to drive a lot of more semantic integrity in a lot of the things we do to make sure that we're using controlled vocabularies, as well as the definitions that go along with that. So you're not just exchanging the data, but you're exchanging the meaning at the same time. I mentioned the scale tickets because everything is that, you saw the handwritten scale ticket there, trying to get a standard API on, we should be able to get digital data from a scale head to a farmer's management system to understand what data goes with what on there. So any questions on data linking? That's a huge thing. Really kind of brushed over it, but so kind of on the what's next, just kind of a little peek at things we're going to be kicking off fairly soon. We've got a weather and forecast data API, so there's a lot of weather data providers out there, a lot of people consuming weather data. They're all different. So we're going to try to see if we can get to an agreed standard on at least, I think we're looking at like 6 different parameters to kind of start with on exchanging that kind of data. Settlement sheet, that kind of came out of the scale ticket work, because once you get a bunch of scale tickets, now I want to settle these things because, 3-4 scale tickets go into one grain contract. So I want to try to start working in that direction. Dairy feed is another one that's kind of come up lately, that there's not a really good standard for exchanging information between the ration balancing software and the herd management systems. And, some of that ties into the MODIS too, where I don't think there's a real good, I don't think the methods are even standardized that well for a lot of the feed documentation. Had some, input from people that a lot of that's NIR data, and how you calibrate your NIR is probably a little bit proprietary, so people might not be sharing as much of that, but some stuff to work on there. Like I mentioned, agri-semantics keeps coming up. That's like I said, we're kind of officially making that a bit more of a standing committee to manage all this stuff, but then we're still going to have working groups to kind of go out and find or create or refine any existing lists that we need. And then we're looking into how to make that more programmatically available, because right now it's not as machine readable. So trying to provide some, maybe we provide a little bit of infrastructure similar to the DDI thing, where somebody can go hit an API and pull down the latest version of the MODIS code list instead of having to download it out of GitHub kind of thing. But then all sorts of other things. Data permissioning is obviously a big thing. We had a white paper that I think that was 2017, so that's been a few years since we released that. It was used in the development of the Ag Data Transparency Evaluator. We probably need some updating and revising since I think we wrote that before GDPR was even a thing. So there's changes that have happened. A lot of different stuff going on that, like I said, we touch a lot of different areas. So a lot of future work. We haven't got everything solved yet. But with that, can open it up to any other questions, comments, or anything I missed or didn't make sense.
Great. Thank you, Ben. Appreciate it. Yeah, feel free to raise your hand or use the chat when you guys have a question. I do have a question, Ben. So related to soil sampling, I know you have the data standards. What about where you sample and how many locations you sample? Have you guys thought about that? Or I know I'm working on some software for the USDA to do that and trying to help come up with some open source tools on directed sampling. I guess, did you have any thoughts there about where these are collected and how many per area should you collect?
So we stay out of trying to recommend how you should do things and just make sure we clearly communicate how that's done. So that's one of the updates to the schema is, having some sort of link to the sampling protocol or whatever you use to, is it an aggregate sample? Is it an individual core? Does it represent an area or a bunch of points? And that's one thing that new schema will do is be able to document that because, a lot of times, like when we talk about repeatability going back every few years, you want to know, well, even if this was an aggregate sample, you might want to know where those individual cores were taken to make that aggregate sample so you can go back. So that's something that we'll cover in that version 2 schema, is being able to clearly identify that kind of thing, because you could do it a little bit in the original MODIS schema, but probably not to the extent that people want to do today. So that's one of the big updates we want to make is, making sure that's clear on how that sample protocol happened, what depth you went to, was obviously part of that. We even got different things where you sampled at this depth, but the core isn't always. If I tried to sample between 6 and 12 inches deep, but I only ended up with a 4-inch core because everything compressed, how do you document that and make sure, because that's important when you're trying to figure out bulk density and all that kind of stuff. So a lot of different stuff we've been going through to make sure we're capturing at least as much as we can about that, to standardize that. And again, like I said, that was one of the way I said that was because there was a little bit of rub additionally that people thought we were going to try to standardize how the methods are done, especially within the lab. And that's where we want to be clear is, no, we're not standardizing that. There's proficiency programs and all that kind of stuff. We're just trying to make sure the data exchange is clear and understandable and, rich, so that you can go back to it year after year and know what happened. And then it's going to be up to the industry to kind of integrate and make sure they're filling out all those fields, especially as you see a lot more of the robotic samplers and things like that. I think we'll get a lot better data than, sending grad students out there with a shovel is probably not as data rich as sending a robot out there and accurately recording what it did.
Okay, but if there were these tools that existed, did you guys link to those and provide awareness, or is that not something that you guys are part of? So if there was like I said, a directed sampling scheme, is that something you guys would be open to linking to, or is that not really part of the, I guess, the ag gateway?
We haven't really got into that side of it. If they're,
So ESAP was the old one that USDA had, Soil Salinity Lab. That was kind of the directed sampling. So that was just kind of curious on that. So
to me, a knee-jerk reaction would be, maybe that's a controlled vocabulary we'd manage within MODIS of here's the different sampling protocols to make sure when somebody documents it, this is the list of known protocols that are out there, or, if somebody's got their own proprietary way of doing it, they can have that added in the list as well. But being able to at least point people to this was the method that was used to determine that.
Okay. There's a question in the chat, a couple questions now. So Brent said, any work being done with data standardization in regards to UAV spray applications and how they are recorded/reported?
So I've been trying to pin a guy down that knows about that. That's something that I think came up fairly recently. Actually, when I was at Dairy Expo, that came up, which is a weird spot for that to happen. But something that I think we're starting to look in as a lot of the UAVs are kind of, the application ones are really starting to take off. I think that's something we need to look into. Again, it's a lot member driven. So, if members are seeing issues on getting data to and from those systems, that's something that we'll look at if people ask about it, because obviously that's going to be a thing. It's not going to go away, and using ISO XML probably doesn't make sense for a drone, is my gut instinct on that. So trying to find some standard way of exchanging that data. A lot of the work we're doing with the ADAPT standard, I think, would be a pretty easy fit, with like I said, here's a polygon on what the attributes of it should be. You can send that to whatever software system the drones are using to control their application to pull that in. Same thing, getting the as applied back. They should have some sort of record to use that. So nothing official yet, but something that a couple members have talked to me about that we're kind of starting to dig around on.
Gotcha. Do a follow-up to that question. Any efforts on standardizing images used for machine vision training?
Not for machine vision training. I'm assuming you're meaning like tagging things for knowing what it is. I know, especially in our European group, they've discussed that on, maybe setting up a working group to again standardize that, as obviously everybody's interested in machine learning and AI and training everything, and being able to get good data sets to train things is difficult from what I understand. So no official working group started on that, but it has popped up on the radar as potentially something we could look into trying to standardize some of that, get some better data sets out there.
Yeah, and I can comment because there is a working group right now, not associated with us, but as part of the Ag to PI effort. There's a group looking at UAV images and image standardization. So they're not necessarily moving to the point of, annotating or labeling images, but at least getting some consistency across the UAV in terms of the software and the types of images. And that's probably that would be next step. Yeah.
And that's when we did have a working, well, this is a while ago that we had that, but we came up with a PIX. It was a post image calibration standard. It was really targeted at aerial imagery, and it was really more metadata. So it kind of said, if you're going to exchange imagery, use GeoTIFF, and then here's like a band order and kind of some of that information, so that even though it's GeoTIFF file, there's not really standard within that. So we have kind of a guideline on how to use a GeoTIFF and some control vocabularies and stuff that we've kind of had sitting on the back shelf and haven't really publicized, but might be relevant for what you're talking about there, where it's not labeling data, but it was more improving the metadata on aerial imagery. So when you get it, it's a little bit easier to understand what you have, like I said, the band order and things like that, to know when you're reading it in what you're working with.
I would probably add that the manufacturers like John Deere have a tremendous investment in capturing those images, and to make that shareable, a freeware would probably, there's money to be had there or made there by licensing that. They had interns running around in South Dakota, North Dakota with cameras for 2 years, running up and down fields, taking pictures of plants.
Yep.
Not surprising. Mm-hmm.
Yep. Yeah, and that's where we try to stick to the business model behind exchanging the data can be independent of the API. Like the weather data one is a good example of that, where there's everybody's exchanging, evapotranspiration, temperature, humidity. Can we agree on how we're going to do that? You can still monetize it however you want. It's just when I go to acquire a new customer, now it's easier because they don't have to develop to my new API. Everybody has the same way of exchanging that data, so it's a little bit easier to acquire new companies or decide to switch providers from either side. How you monetize that's up to you. We're really just trying to say, we're not going to compete on data formats. Let's agree that that's not going to be how we win. It's going to be what we provide or what we do with that.
Any other questions in the chat? Looks like there's just a couple of pieces of information for you in the chat there. Ben, I put in the soil sampling tool and then the UAV standards, a couple groups working on that. So any other questions from the group? All right, Jennifer, any updates on the white paper, I guess, or I know the next webinar is in November.
Next webinar is November, and it'll be on dairy and data management. And then the white paper, literally I was working on it right before this webinar, so it's sitting in my lap. I'm trying to get it down to less than 10 pages, but hopefully have it done the next week or two, and then we'll have a request for applications for pilot projects. I'm aiming for early November, so stay tuned.
Great. Thanks, everyone. We'll hopefully see you in November.
Perfect. Thank you all.
Thanks, everybody.